Okay, welcome. So in this video we're going to start talking about financial applications involving growth, exponential growth. So one of the things we're going to talk about is compound interest. But before I introduce compound interest, let's talk about simple interest. Simple interest, so let's take, we have $1,000. So we'll take $1,000 and we're going to basically borrow the $1,000 or invest the $1,000 for a year. And let's say you get a 2% rate of return. So that's an annual rate of return. And so you're going to put in a bank that offers 2% and you're going to leave it there for a year. And this is going to be simple interest, which means you're just being paid interest on the amount that's in there for the time that you have it in there. So it's a one and done sort of thing. You only get charged once on the interest. So what happens? Well, 2% of the $1,000 is what? Right? 2% of the $1,000 is $20. Right? So 0.02 times this gives you $20. So what happens at the end of the year? You basically get your $1,000 plus the extra $20 for interest, and so now you have $1,020 in your account. Now, compound interest means that you're getting paid, you're getting interest not at the end of the loan period or the investment period. You are getting credit for some of the interest throughout the period that you have it in there. So what do I mean by that? Let's just use an example. So let's take the $1,000. And again, you're getting the 2% rate of return. But this time, let's say your bank compounds your interest every 6 months. So that means after the first 6 months, they're going to credit you the interest up to that point. So in other words, what they're going to do is they take the 2% and they split it up. 1% for the first 6 months, 1% for the second 6 months of the year. So what happens is at the end of the first 6 months, they're going to they're going to credit your account the interest, which means they're going to add 1% of your balance as interest, right? So what they're going to do is they're going to take 1% of the $1,000, which is $10, and they're going to add that to your account at the end of the 6 months. So at the end of the first 6 months, now you have, $1,010, and now for the second half of the month, now you're not only earning the interest, the 1% on the $1,000, but you're earning the interest on the $1,000 plus the extra $10 that you got after the first 6 months. So that means now at the end of the first 6 months, you're going to earn 1% of that amount, which is going to be $10.10. And so then what happens to your balance at the end of the year? It's going to be what? So it's going to be $1,020.20. Or excuse me, 10 cents. I wrote that down wrong. Okay, so that's the instance of compound interest. So what does that formula look like? Well, mathematically, it would look like this for this case, right? For this case, it's compounding every 6 months or semi-annually. So your total amount earned would be this. Okay? And now this is what you would accumulate after 1 year. What if it was compounded every 4 months? If it was every 4 months, then how many compounds in the year would there be? There'd be 3. So they would divide the percentage, the annual percentage, over those after every 4 months. And then how many compounds would there be? There'd be 3. So we do it 3 times. Okay? And what if it was every 3 months? Well, then now you would have quarterly compounding, and so now this would become 4, and it would be done 4 times. So you would be dividing it into a quarterly percentage, and you'd be compounding 4 times. Okay? So in general, what would be happening as we did this, even if we did it daily, we would have 365. 365, right? So, in other words, how many times is it going to compound? And so let's do this n to the n, right? And so, what would that look like? So, and again, this is going to be done over a year. Okay, now, what if we added time to it? What if we added time? Well, that means that we're going to be compounding this over a certain period of time, not just 1 year, maybe it's t years. Well, then what we're going to do is we're going to add t to the product of here, because this would give us the total number of compounds over t number of years. Because what were we assuming? We were assuming 1 year. So this was just 1 for t. So now what we're going to do is let's assume that we're doing this over t years. And so now our formula looks like this. Now, what happens if I want to take this as a limit? What if I want n to go to infinity? So now what I'm going to do is I'm going to rewrite this, and I'm going to pull the 1,000 out. It's just a constant. So now I'm going to take the limit as n approaches infinity of 1 plus 0.02 n to the nt. Okay, so now this is where we're going to recall the limit definition of e, the number e. Okay? Okay? So what is that formula? So note. Okay, so note E is equal to the limit as n, let's use m. Let's use m. Limit as m approaches infinity. And so what does that look like? The limit definition is this: 1 plus 1 over m to the m. Okay, so that's the limit definition of the number e. So we want the inside expression. So we want the inside expression here to look like this. So how can we do that? So we'll just have to manipulate the expression, right? So let n, we need a 1 up here. So let n equal 0.02 m. Okay, so let n, so let me write it down here. So let n equal 0.02 m. And if we do that, what do we get? We get 1,000 times the limit as n approaches infinity. Let's do m, since we're dealing with m now. M approaches infinity of 1 plus 0.02 over 0.02 m, right? I just substituted. And then this becomes what? Just 1 over m. 1 over m. Now, what happens up here? This becomes 0.02 mt, right? Now, what I'm going to do is, now I'm going to manipulate, because I'm going to bring the m inside, and write this as a power of a power. So now what happens is, this is going to equal 1,000 times the limit as m approaches infinity. I'm going to put a bracket there. And then what I'm going to do is I'm going to take 1 plus 1 over m to the m. I'm going to bracket that. Right? And I'm going to pull the m in, right, like that. And then the rest is going to be 0.02 t. Now, this inside here is e. And so this becomes what we call continuous compounding, is 1,000 e to the 0.02 t. Okay? Now, in general, we write this as P equals e to the RT, where P is the balance. Or, I'm sorry. So P P is the initial balance, or the principal. E is just the number E. R is the annual rate as a decimal, and then T is time in years. And then A is the accumulated amount, or future value. Okay? And this is the formula for continuous compounding. Okay? And then the formula for compounding in general is given by A equals 1 plus R over N to the NT. So this is what we were using here. Okay? But then if we take the limit as N approaches infinity, we get continuous compounding, which is that. Okay? Now, I'm going to leave it there because we're going to do some examples and then talk about some other things that are going to involve integrals. So we're going to get there. So it's not just about algebra, but we're going to get to where we're going to use integrals. Okay, talk to you soon.